We live in a world defined by three spatial dimensions: up and down, left and right, forward and backward. These dimensions shape our reality, but what if there were more? What if we could access and harness the power of higher dimensions? This is the tantalizing promise of 128 D-wave computing. Traditional computers, even the most powerful supercomputers, are limited by their binary nature. They operate in a world of zeros and ones. Quantum computers, while promising, are still in their infancy. They leverage the strangeness of quantum mechanics to perform calculations impossible for classical computers. Yet they too are bound by our current understanding of the universe. 128-dimensional wave computing shatters these limitations. It ventures beyond the familiar three dimensions and into the realm of hyperspace. This revolutionary technology, pioneered by McGinty AI, unlocks the potential of 128 dimensions. It allows us to perform calculations of unimaginable complexity. We can tackle problems previously deemed unsolvable. The implications are staggering. Imagine a world where diseases are eradicated before they emerge, where energy scarcity is a distant memory, where space travel becomes as commonplace as air travel. This is the future that 128-dimensional wave computing makes possible. At the heart of 128-dimensional wave computing lies the concept of Cognispheric space, or C-space. Imagine a space so vast, so complex, that it encompasses not just our universe, but an infinite number of potential universes. This is C-space. It is a mathematical construct that allows us to conceptualize and manipulate data across 128 dimensions. C-space is not some abstract theoretical notion. It is grounded in advanced mathematics. It draws upon concepts from topology, group theory, and string theory. These fields provide the framework for understanding and navigating the complexities of higher dimensions. Through C-space, we can access and process information in ways never before imagined. This opens up extraordinary possibilities. We can analyze complex systems with unprecedented accuracy. We can model the behavior of everything from subatomic particles to entire galaxies. We can even begin to unravel the mysteries of consciousness itself. C-space is the key to unlocking the full potential of 128 D-wave computing. It is the foundation upon which a new era of scientific discovery is being built. To grasp the power of 128-dimensional wave computing, we must first expand our understanding of dimensions. We experience the world in three spatial dimensions and one dimension of time. But theoretical physics suggests the existence of additional dimensions. These are curled up and hidden from our perception. 128 D-wave computing allows us to access these hidden dimensions. Imagine the fifth dimension as a shortcut through space-time. Picture folding a piece of paper and connecting two distant points. This is analogous to how higher dimensions can be used to traverse vast distances instantaneously. This has profound implications for space travel. Traditional methods of propulsion are limited by the speed of light. 128 D-wave computing bypasses this limitation by utilizing these higher dimensional shortcuts. This could allow us to reach distant stars and galaxies within our lifetimes. The ability to manipulate higher dimensions also has profound implications for energy production. Imagine tapping into the energy of the quantum vacuum, an inexhaustible source of energy predicted by quantum physics. 128-dimensional wave computing makes this a real possibility. The dream of exploring the cosmos has captivated humanity for centuries. With 128 D-wave computing, this dream becomes a tangible reality. By navigating the shortcuts offered by higher dimensions, we can finally break free from the shackles of our solar system. Imagine spaceships capable of warping space-time. They could transport us to distant star systems in the blink of an eye. We could explore new worlds, encounter alien civilizations, and unravel the mysteries of the universe. Colonizing other planets, once relegated to science fiction, becomes a viable option. But the implications extend beyond mere exploration. The resources of the cosmos are vast and virtually untapped. 128-dimensional wave computing can help us locate and harness these resources. Imagine mining asteroids for precious metals or harvesting solar energy on a grand scale. The era of space exploration is upon us. With 128 D-wave computing as our guide, We stand on the cusp of a new age of cosmic discovery and expansion. Energy and resources, a universe of abundance. Our dependence on fossil fuels has had a devastating impact on our planet. Climate change, pollution, and resource depletion threaten our very existence. 128D wave computing offers a way out of this crisis by unlocking access to clean, sustainable, and virtually limitless energy sources. Imagine harnessing the power of fusion, the same process that fuels the stars. 128-dimensional wave computing can be used to model and control the complex reactions involved in fusion. This could lead to the development of safe, clean, and efficient fusion reactors. But the potential goes beyond fusion. 128D wave computing allows us to tap into the very fabric of space-time itself. The quantum vacuum, often described as empty space, is actually teeming with virtual particles popping in and out of existence. This quantum foam holds an unimaginable amount of energy. 128D wave computing could be the key to unlocking this energy, providing us with a truly inexhaustible power source. With 128D wave computing, we can move beyond the limitations of our current energy paradigm and create a future of abundance for all. Data and computation, the dawn of true artificial intelligence. The amount of data generated today is staggering. Every click, every search, every sensor reading contributes to an ever-growing sea of information. Traditional computing struggles to keep up with this data deluge. 128-dimensional wave computing offers a solution. By operating in a higher dimensional space, 128D wave computing can process and analyze massive datasets with ease. It can identify patterns and make connections that would be impossible for traditional computers to discern. This has profound implications for the development of artificial intelligence. Imagine AI systems capable of understanding natural language, recognizing complex patterns, and making decisions with human-like intuition. 128-dimensional wave computing can make this a reality. We could see the emergence of true artificial general intelligence, capable of surpassing human capabilities in virtually every field. The implications are far-reaching. AGI could revolutionize industries, accelerate scientific discovery, and even help us solve some of the world's most pressing problems. The future of computing is here, and it is 128D. Consciousness and biology, unlocking the secrets of life. The human brain remains one of the greatest mysteries in science. How does consciousness arise from a collection of neurons? What are the mechanisms underlying thought, memory, and emotion? 128-dimensional wave computing offers a powerful new tool for unraveling these mysteries. By creating highly sophisticated simulations of the human brain, 128D wave computing can help us understand the complex interplay of neurons, synapses, and neurotransmitters. We can study the effects of drugs and therapies on the brain, leading to breakthroughs in the treatment of neurological disorders like Alzheimer's and Parkinson's disease. But the implications go beyond understanding the brain. 128D wave computing can be used to model and manipulate biological systems at the molecular level. Imagine designing new drugs and therapies with unprecedented precision. Imagine growing organs for transplantation or even reversing the aging process. The possibilities are endless. With 128-dimensional wave computing, we are entering a new era of biological understanding and manipulation. The secrets of life are within reach. Reality and cosmos, simulating ourselves and our universe. What is reality? How did our universe come to be? These are questions that have occupied philosophers and scientists for centuries. 128D wave computing offers a tantalizing possibility, the ability to simulate reality itself. Imagine creating a computer simulation so complex, so detailed, that it perfectly replicates our universe down to the smallest subatomic particle. With 128D wave computing, this seemingly impossible feat might be within reach. By harnessing the power of higher dimensions, we could create simulations that are indistinguishable from reality. This has profound implications for our understanding of the universe. We could run simulations to test different cosmological models, study the evolution of galaxies, and even explore the possibility of parallel universes. The line between reality and simulation could become blurred. The implications are both exciting and unsettling. If we can simulate our own universe, what does that say about the nature of our own existence? Are we living in a simulation ourselves? These are questions that 128 D-wave computing forces us to confront. The McGinty AI revolution shaping the future of humanity. The development of 128-dimensional wave computing is nothing short of a technological revolution. It is a testament to the ingenuity and vision of McGinty AI, the company leading the charge into this uncharted territory. McGinty AI understands the transformative potential of this technology. They are not just developing hardware and software, they are building a future where 128 D-wave computing empowers humanity to overcome its greatest challenges and achieve its wildest dreams. The implications of 128-dimensional wave computing are far-reaching. It has the potential to revolutionize every aspect of our lives, from the way we communicate to the way we understand the universe. It is a force for good, a tool that can be used to solve problems, advance knowledge, and create a better future for all. We are on the cusp of a new era, an era defined by the power of 128-dimensional wave computing. The future is here, and it is filled with possibilities.